Right now, you're using technology to watch this video, maybe on a smartphone engineered with billion transistor processors, maybe on a computer connected to a global network of information. You're probably sitting in a building constructed with materials sourced from around the world, assembled using knowledge accumulated over thousands of years. You speak a language with thousands of words. You can read, write, plan for tomorrow, remember yesterday, imagine things that don't exist, and then figure out how to make them real. Now here's what's crazy. A human from 200,000 years ago would have looked almost identical to you. Same size brain, same body, same basic biology. If you dressed them in modern clothes and put them on a subway, you probably wouldn't notice anything unusual. Anatomically, they were us. But behaviorally, they were living in a completely different world. For roughly 150,000 years, these anatomically modern humans existed on Earth, doing essentially the same things generation after generation. Simple stone tools, small groups, no art, no jewellery, no evidence of complex language or abstract thinking, no indication that they were destined to become the most dominant species the planet has ever seen. Then, around 50,000 years ago, something changed. And when I say something changed, I mean everything exploded. Suddenly, humans are creating sophisticated tools. They're making art, carving figurines, painting cave walls with stunning images of animals and symbols. They're crafting jewelry, developing complex weapons, inventing new technologies at a pace never seen before. They're burying their dead with elaborate rituals. They're building boats and crossing oceans. They're moving into environments that should have killed them, from frozen tundras to scorching deserts, and thriving. Within just 30,000 years, a blink of an eye in the evolutionary time, humans had spread to every continent except Antarctica. They'd driven multiple other human species to extinction. They'd wiped out megafauna that had dominated their ecosystems for millions of years. They'd developed hundreds of distinct cultures, languages, and technologies. The planet had never seen anything like it. If you're watching this to fall asleep, perfect. That's exactly why I make these videos. So maybe subscribe and tell me where you are and what time it is right now. I love checking comments and seeing Tokyo at lunch, London at midnight, Sao Paulo at dinner, all experiencing this story together. So what happened? What changed around 50,000 years ago that turned anatomically modern humans who'd been doing the same basic things for 150,000 years into the creative, innovative, world-conquering species we recognize today? This is the central mystery of human evolution. Scientists call it the cognitive revolution, the Great Leap Forward, the Upper Paleolithic revolution. Whatever you call it, it's the moment when humans stopped being just another clever ape and became something unprecedented in Earth's history. Was it a genetic mutation that rewired our brains, a cultural innovation that spread like wildfire, a change in population size that allowed new ideas to accumulate, the mastery of complex language that let us share knowledge across generations, or something else entirely that we haven't figured out yet? Here's what makes this mystery even more fascinating. We know when this transformation happened. We can see it clearly in the archaeological record. Around 50,000 years ago, human sites suddenly start showing up packed with evidence of symbolic thinking, technological innovation, and cultural complexity. But understanding when something happened isn't the same as understanding why. For decades, anthropologists have been locked in fierce debate. Some argue the change was sudden, triggered by a specific genetic mutation that gave us modern cognition. Others insist it was gradual, that the seeds of modern behavior were always there, just waiting for the right environmental conditions to flourish. Still others point to cultural evolution, arguing that humans crossed some critical threshold where population density allowed innovations to spread faster than they could be lost. The truth is probably somewhere in the middle of all these theories, but to understand what happened at 50,000 years ago, we need to start at the beginning. We need to trace the full 250,000-year journey of Homo sapiens from our origins in Africa to the moment we became truly unstoppable. This is a story about transformation, about a species that spent 80% of its existence doing almost nothing remarkable, then suddenly became remarkable at everything. It's about the long, slow burn of human potential and the explosive moment when that potential was finally unleashed. So let's go back, way back, to where it all began in the African landscape 250,000 years ago, when the first anatomically modern humans were taking their first breaths, with absolutely no idea that their distant descendants would one day walk on the moon. Let's go back to the very beginning, not to the bottleneck we just discussed, not to the three-species divergence, but to the actual origin point. The moment when something that wasn't quite us became something that was. Around 250,000 years ago, somewhere in East Africa, the first humans who would look anatomically modern to our eyes were being born. They weren't appearing out of nowhere. Evolution doesn't work that way. They were emerging gradually from earlier hominin populations, probably Homo heidelbergensis, through thousands of generations of incremental change. But at some point the changes accumulated enough that we can point to fossil skulls and say, that's one of us, that's Homo sapiens. Now here's what's wild about this transition. These early humans had almost everything we have physically. Take a skeleton from 250,000 years ago, clean it up, put it in a modern anatomy textbook, and most students wouldn't notice anything unusual. The skull shape, more rounded and less angular than earlier hominins. Check. The face, flatter and tucked under the brain case rather than projecting forward. Check. The chin, actually present instead of just a sloping jawline. Check. The body proportions, tall and linear, adapted for efficient heat dissipation in tropical climates. Check. Their brains were essentially our size. Around 1,400 cubic centimeters on average, which is right in the modern human range. Some individuals actually had slightly larger brains than the average person today. So physically, neurologically, anatomically, these were modern humans. If you could somehow grab a baby from 250,000 years ago and raise them in modern society, they'd fit right in. They'd learn to read, use smartphones, probably complain about traffic and argue on social media, just like everyone else. But here's the thing that's puzzled archaeologists for decades. Despite having modern brains and modern bodies, these early humans weren't doing particularly modern things, and understanding why requires understanding the world they lived in. Picture Africa 250,000 years ago. This isn't the Africa you see in nature documentaries. This is Ice Age Africa, and it's nothing like you'd imagine. While massive ice sheets were covering Europe and North America, Africa wasn't tropical and lush. It was going through wild climate swings, periods of intense aridity punctuated by brief wet phases, lakes that filled and emptied over thousands of years, forests that expanded and contracted, grasslands that turned to desert and back again. The human populations trying to survive in this environment were small, not just small, but fragmented, scattered across vast territories in tiny groups that might go years without encountering other humans. We're talking populations in the low thousands, maybe tens of thousands at most. These aren't cities or even villages. These are extended family bands of 20 to 40 individuals, camping near water sources, following animal herds, gathering whatever plant foods they could find. The fossil evidence for these earliest modern humans is maddeningly sparse. We have skulls from Homo kibish in Ethiopia, dated to around 233,000 years ago. Fragmentary but clearly modern in their basic structure. We have the Herto skulls from Ethiopia, around 160,000 years old, showing fully modern anatomy. And remarkably, we have fossils from Jebel Ehud in Morocco, dated to around 315,000 years ago, that show a mix of archaic and modern features, suggesting the transition to modern humans might have begun even earlier than we thought. But here's what we don't have. We don't have much evidence that these people were doing anything particularly special with those big modern brains. The stone tools from this period, what archaeologists call the Middle Stone Age in Africa, are certainly more sophisticated than what came before. They're making carefully shaped points, probably for spears. They're creating scrapers and cutting tools with specific functions. They understand heat treatment, learning that you can improve the quality of certain stones by heating them in fires before working them. This is genuine technological innovation. These aren't just picking up rocks and bashing them together. They're planning, they're understanding material properties, they're teaching these skills to their children. But here's the puzzling part. This technology doesn't change much. Look at stone tools from 250,000 years ago, then look at tools from 200,000 years ago. They're remarkably similar. Same basic designs, same manufacturing techniques, same functions. There's innovation, but it's incredibly slow. If these people had fully modern cognitive abilities, why weren't they innovating faster? The answer probably lies in those population numbers. Remember, we're talking about tiny scattered groups, isolated from each other by hundreds of miles of hostile territory. When you have a population of only a few thousand people spread across 1 million square kilometers, innovation becomes incredibly difficult to sustain. Sure, maybe one genius in one group figures out a better way to make spear points or process plant foods. But if that knowledge doesn't spread to other groups, it dies with them. One drought, one disease outbreak, one hunting accident, and that innovation is gone forever. This is the cruel mathematics of small populations. Innovation requires not just intelligence, but also numbers. You need enough people that someone occasionally has a brilliant idea. You need enough social connections that the idea can spread. You need enough stability that knowledge can be preserved across generations. Early Homo sapiens had the intelligence, but they didn't have the numbers or the connectivity. They were trapped in what anthropologists call a low-density equilibrium, smart enough to innovate, but too scattered and too few to build on those innovations systematically. The environment they lived in made everything harder. Africa during this period was characterized by what climate scientists call high variance. Not just that conditions were harsh, but that they kept changing. A valley that provided abundant resources for one generation might become uninhabitable desert in the next. Water sources that had been reliable for decades could dry up in a single year. Animal populations would boom and crash unpredictably. Under these conditions, survival required not specialization but flexibility. You couldn't afford to become too dependent on any single resource or any single strategy. You needed to maintain a broad toolkit capable of exploiting whatever opportunities presented themselves. This selected for intelligence and adaptability, but it worked against the kind of cumulative cultural evolution that drives rapid technological change. Think about it from the perspective of a band trying to survive. You've got maybe 30 people. a few children who need constant care and protection, a few elderly individuals who can no longer hunt effectively, but who carry crucial knowledge about past climate cycles and distant resources, and a group of adults who need to spend most of their time finding food, processing it, and dealing with the constant challenges of survival in a harsh and unpredictable environment. How much time and energy can you devote to experimentation? How much can you afford to risk on unproven innovations? If you're barely surviving with known techniques, adopting an unproven new method could mean death for your entire group. So, you stick with what works. You teach your children the same skills your parents taught you. You maintain the traditions that have kept your lineage alive for thousands of generations. This conservative approach to survival makes perfect sense from an evolutionary perspective. The groups that survived were the ones that didn't take unnecessary risks. Natural selection favored caution, tradition, and the preservation of proven knowledge. Innovation happened, but slowly, cautiously, only when circumstances really demanded it. The archaeological record from this period reflects this reality. We see the same basic Middle Stone Age technology across vast regions of Africa. There's regional variation, sure, different groups developing slightly different styles and techniques adapted to their local environments. But there's no exponential acceleration of innovation, no sudden explosion of new technologies or new behaviors. What we also don't see is much evidence of symbolic behavior. There's no art, no jewelry, no burial practices with grave goods, no clear evidence that these people were creating symbols or engaging in the kind of abstract reasoning that characterizes modern human behavior. They probably had language. Almost certainly, in fact, because you can't maintain the kind of social coordination they needed without sophisticated communication. But they weren't leaving us messages. They weren't making marks on cave walls or carving figurines or creating ornaments. Does this mean they couldn't? That their brains were somehow not quite capable of symbolic thinking despite being anatomically modern? Probably not. More likely they could, but they didn't need to. Or perhaps more accurately, they didn't have the population size, the social complexity, and the environmental stability that would make symbolic behavior advantageous enough to invest the time and resources in developing it. You have to remember, creating art or jewelry or elaborate burial rituals requires surplus. Surplus time, surplus energy, surplus resources. It requires a level of security where you can afford to expend effort on things that don't immediately contribute to survival. These early humans weren't there yet. They were still in survival mode, still living generation to generation, still hoping that the rains would come and the herds would return and that they could make it through another year. But they were surviving. Despite everything working against them, the small populations, the harsh environments, the limited technology, they were hanging on. And in surviving, they were accumulating something precious. Not artifacts that archaeologists would later find, but knowledge. Knowledge about their environment, about animal behavior, about plant properties, about weather patterns. Knowledge encoded in stories passed from grandparents to grandchildren. Knowledge embedded in traditions and techniques that might seem simple, but represented generations of trial and error and hard-won wisdom. They were also accumulating something else, genetic adaptations. Natural selection was constantly at work, favouring individuals who were just a bit smarter, a bit more socially skilled, a bit better at learning and teaching. These advantages were tiny, maybe improving survival by just a few %. But over thousands of generations, those tiny advantages accumulated into something substantial. So by 200,000 years ago, we have a species that looks fully modern. thinks in fundamentally modern ways but doesn't yet act particularly modern. They're poised on the edge of something transformative, but they haven't crossed that threshold yet. They're the seed from which modern human culture would eventually grow, but the conditions for that growth haven't yet materialized. They couldn't know what was coming. They couldn't know that their descendants would face near extinction, that survivors of that bottleneck would split into 3 species, that eventually one of those species would come to dominate the entire planet. They were just trying to survive another day, another season, another generation. But they did survive, and in surviving they set the stage for everything that came after. So we've established that anatomically modern humans emerged around 200,000 years ago. We've seen them survive climate disasters and begin spreading across Africa. Now comes the part of the story that's going to challenge everything you think you know about human evolution. Because here's the uncomfortable truth. For the next 100,000 years, almost nothing happened. I know that sounds boring. I know we want the story of humanity to be one of constant progress, relentless innovation, an inevitable march towards civilization. But that's not what the evidence shows. What the evidence shows is 100 millennia of humans who look just like us, had brains just like ours, but lived in ways that would have been completely recognizable to their ancestors from hundreds of thousands of years earlier. Let that sink in for a moment. 100,000 years. That's twice as long as writing has existed, 4 times longer than agriculture, 20 times longer than recorded history. And for all that time, human culture barely changed. Picture yourself back there, somewhere around 180,000 years ago. You're part of a small group, maybe 20 or 30 people, living somewhere in Eastern Africa. Your days are consumed with survival. Finding food, avoiding predators, dealing with the endless cycles of drought and rain. You make tools, sure. Stone tools that your ancestors would have recognized immediately. Hand axes that haven't changed in design for 500,000 years. Simple spear points, scrapers for processing animal hides. You're smart. Absolutely as smart as any modern human. Your brain is the same size as mine, structured the same way, capable of the same thoughts. But you're not using that brain the way we do today. You're not inventing new technologies every generation. You're not creating art or writing or mathematics or agriculture. You're surviving. That's it. Just surviving. And here's the truly humbling part. You weren't alone. Neanderthals were doing the same thing in Europe. Robust, cold-adapted, just as intelligent as you, making stone tools that looked remarkably similar to yours despite being separated by thousands of miles. Denisovans were spreading across Asia, developing their own survival strategies, their own tool traditions. All 3 species of humans, all equally smart, all equally capable, all essentially stuck in neutral. The archaeological record from this period is frustratingly repetitive. Site after site shows the same basic toolkit, the same simple stone implements, appearing again and again with almost no variation. Archaeologists have a name for this technology. They call it the Middle Stone Age in Africa, the Middle Paleolithic in Europe. But really they could call it the Age of Sameness. Because for 100,000 years that's what it was. The same tools, the same techniques, the same survival strategies, generation after generation after generation. Now this doesn't mean nothing was happening. Climate was still throwing everything it had at our ancestors. Between 200,000 and 100,000 years ago, Africa went through multiple cycles of expansion and contraction. Wet phases when the Sahara turned green and humans could spread across territories that are desert today. dry phases when populations retreated to refuges near rivers and lakes, clinging to survival while thousands died. The genetic evidence shows just how close we came to extinction during this period. Multiple population bottlenecks, times when the number of breeding humans dropped to dangerously low levels. Some estimates suggest there were periods when the entire human population of Africa might have been as low as 10,000 individuals. That's less than fill a small stadium. Every human alive today, all 8 billion of us, descended from that tiny group of survivors. These bottlenecks weren't accidents. They were the inevitable result of climate fluctuations hitting populations that didn't have the technology to buffer themselves against environmental disasters. When the rains failed, people starved. When disease swept through, whole groups disappeared. When volcanic eruptions or droughts made territories uninhabitable, populations collapsed. Put yourself back there again, this time during one of those crisis periods. Maybe 140,000 years ago, when a particularly severe drought is gripping Eastern Africa. Your group used to number 40 people. Now you're down to 15. Half the children born in the last 5 years have died. The elders tell stories about better times, about territories to the north that used to have reliable water, but those places are desert now. You're living off roots and whatever small animals you can trap, because the big game has moved away or died off entirely. You're smart enough to understand what's happening, smart enough to feel despair, but you don't have the tools to fix it. You can't dig deep wells to reach groundwater. You can't store food for years at a time. You can't move your entire group hundreds of miles to find better territory, because you don't have the social networks or the technology to sustain such a journey. So you stay put, and you hope the rains come back before everyone dies. Sometimes they do, sometimes they don't. This was the reality for our ancestors during the Long Plateau. Constant crisis management. Populations expanding when conditions improved, contracting when they worsened, knowledge being lost and relearned over and over again as groups went extinct and survivors had to rebuild from scratch. But every so often there were hints, tiny glimmers that suggested something different might be possible. Around 100,000 years ago, at a cave site called Blombos in South Africa, some humans did something remarkable. They started collecting ochre, red iron oxide pigment that they ground into powder and mixed with fat or bone marrow. They weren't using it for practical purposes, at least not primarily. They were using it to make patterns, abstract engravings on pieces of ochre, geometric designs that served no obvious survival function. They were creating symbols. This is huge. This is evidence of abstract thinking, the ability to represent ideas with marks and patterns. It's the first step toward writing, toward art, toward all the symbolic systems that make human culture possible. But here's what's weird. These ochre engravings appear, persist for a few thousand years, and then disappear from the archaeological record. Later groups in the same region don't seem to use ochre the same way. The innovation doesn't spread. It doesn't take hold. It's like someone invented the wheel, used it for a generation, and then everyone forgot about it. This pattern repeats throughout the Long Plateau. Occasional flashes of innovation that don't go anywhere. A few sites show evidence of more sophisticated tool-making techniques. Others have unusual bone artifacts that might have been decorative. One site in Morocco from around 120,000 years ago shows evidence of marine resource exploitation, people systematically harvesting shellfish from coastal areas. All of these are impressive. All of them suggest our ancestors were capable of innovation. But none of them spread. None of them transform human culture the way later innovations would. And then there were the expeditions. Around 120,000 years ago, during a wet phase when the Sahara was crossable, some human groups left Africa. We know this because we've found their remains. In Israel, at sites like Skul and Kafsa, archaeologists have discovered anatomically modern human fossils dated to around 120,000 years ago. These people made it out of Africa, established themselves in the Middle East, and lived there for thousands of years. But they didn't go farther. They didn't spread into Europe or Asia, and eventually they disappeared. Maybe they were outcompeted by Neanderthals who'd been living in the region much longer and were better adapted to local conditions. Maybe climate change made their territories uninhabitable. Maybe they just went extinct, the way small populations sometimes do. Whatever happened, these early pioneers left no descendants. The humans living outside Africa today don't trace their ancestry to this first migration. They came from a later, more successful expansion. This tells us something important about the long plateau. Our ancestors had the physical ability to leave Africa and colonize new territories. They had the intelligence and the adaptability. What they lacked was something else. Some combination of cultural knowledge, social organization, and technological capability that would let them outcompete other human species and thrive in new environments. Meanwhile, Neanderthals were doing just fine in Europe. Better than fine, actually. They'd been there for over 100,000 years by this point, perfectly adapted to Ice Age conditions. They were master hunters, taking down woolly mammoths and woolly rhinos with sophisticated group tactics. They were making complex tools, including hafted spears that required multiple manufacturing steps and careful planning. They had fire, clothing, possibly even primitive shelters. In every meaningful way, they were just as advanced as modern humans during this period. Maybe more so. The Denisovans were equally successful in Asia. Genetic evidence shows they'd spread from Siberia to Southeast Asia, adapting to everything from Arctic tundra to tropical forests. They were interbreeding with local human populations, exchanging genes and probably cultural knowledge. They were survivors, just like us. So why weren't modern humans special yet? Why weren't we out competing these other species, inventing new technologies, transforming the world? The honest answer is that we don't fully know, but we can make some educated guesses. First, population size matters. Innovation requires a critical mass of people. You need enough individuals that someone, somewhere, will stumble onto a new technique or tool design. And you need enough population density that innovations can spread before the inventor dies. During the long plateau, human populations were small and scattered. Groups were isolated from each other for generations at a time. Under these conditions, even good innovations might not spread far. Second, knowledge is fragile. It can be lost faster than it's gained, especially in small populations facing repeated crises. When a group drops from 50 people to 10 during a drought, they don't just lose bodies, they lose the specialized knowledge those individuals carried. The best toolmaker dies, and suddenly, nobody knows how to make those particularly fine spear points. The healer dies, and knowledge of which plants cure which diseases disappears. The storyteller who remembered the routes to distant water sources dies, and that geographic knowledge is gone. Multiply this across thousands of groups over thousands of years, and you get stagnation. Third, maybe the environment itself wasn't demanding enough. As harsh as this sounds, crisis drives innovation. When you're barely surviving, you don't have time or energy to experiment with new techniques. But when you're comfortable, you don't have motivation to change. The long plateau might have been a Goldilocks problem in reverse. Conditions were just tolerable enough that humans could survive using the same old techniques, but just harsh enough that they didn't have surplus resources to invest in innovation. Whatever the reasons, the result was clear. For 100,000 years, humans remained just another hominin species. Smart, adaptable, but not special. Not yet. But that was about to change, because around 100,000 years ago, things started getting interesting. Something was stirring in Africa. After hundreds of thousands of years of slow, grinding survival, your ancestors started doing things that would have seemed completely pointless to earlier humans. They started making art. Picture this. It's around 100,000 years ago. You're in a cave along the southern coast of what is now South Africa. Your group has been coming to this place for generations, camping here when the fishing is good, when the shellfish beds are full. But tonight someone does something different. They take a piece of red ochre, that iron-rich mineral humans have been collecting for millennia, and instead of just grinding it for body paint or hide preparation, they carve patterns into it. Geometric designs, crosshatches, parallel lines. This piece of ochre will eventually be discovered at Blombos Cave, and it will be 77,000 years old. One of the earliest known examples of abstract symbolic representation in human history. But here's what's incredible. It's not alone. All across Africa during this period, between 100,000 and 70,000 years ago, archaeological sites start showing up with evidence that humans were doing more than just surviving. They were thinking symbolically. They were creating meaning. Shell beads appear in multiple locations, carefully selected, deliberately perforated, strung together to make jewelry or decorative items. These aren't random shells. They're specific species, often collected from beaches dozens of miles away from where they are eventually found. Someone was traveling specifically to get these shells. Someone valued them enough to carry them back across difficult terrain. Someone cared about how they looked. This is profound. This is the difference between a brain that solves problems and a mind that creates meaning. A chimpanzee can use a stick to fish for termites. That's tool use. That's problem solving. But no chimpanzee has ever worn jewelry. No chimpanzee has ever decorated themselves for the simple pleasure of looking different, of expressing identity, of saying, "This is who I am." Your ancestors were crossing a cognitive threshold that no other species had ever reached. They were becoming capable of abstract thought, of symbolic representation, of art. But they are also becoming something else, more technologically sophisticated than any humans who had come before. The tools from this period tell a fascinating story. For millions of years, human stone tools had followed a basic pattern. Take a rock, hit it with another rock until you get something with a sharp edge. Use it for whatever you need. Throw it away when you're done. Simple, effective, but limited. Around 100,000 years ago, that pattern started changing. Tools become composite. Instead of a single piece of stone, you now have stone points carefully shaped and attached to wooden shafts using plant resins, animal sinew, even natural adhesives made from processing tree gum. This is hafting technology, and it represents a massive cognitive leap. Think about what's required to make a hafted spear. First, you need to understand that combining materials creates something more effective than either material alone. That's abstract reasoning. Second, you need to plan ahead. You can't just grab whatever's lying around. You need to find the right stone, shape it precisely, locate a suitable wooden shaft, gather adhesive materials, sometimes heat treat them to improve their properties. The whole process might take days and require materials from different locations. Third, and most remarkably, you need to be able to maintain a mental template of the finished product throughout the entire process. You're working towards something that doesn't exist yet, something you're holding as a concept in your mind. That's imagination. That's the same cognitive capacity that lets humans design buildings, write symphonies, send rockets to Mars. Your ancestors 100,000 years ago had that capacity. They were thinking like modern humans, even if they didn't yet look or act fully modern. But they were also doing something that suggests even more sophisticated mental abilities. They were trading. The archaeological evidence from this period shows raw materials moving across landscapes in ways they never had before. Obsidian from volcanic regions shows up hundreds of miles away. High-quality stone for tool-making appears in places where it doesn't naturally occur. Shells from specific coastlines are found far inland. Someone was moving these materials and probably not just picking them up randomly while travelling. This looks like trade. Intentional exchange of goods between groups, which means your ancestors had developed something incredibly complex. Economic relationships across distances. Think about what trade requires. You need to recognize that different places have different resources. You need to establish relationships with people in other regions, relationships based on trust and mutual benefit. You need to understand reciprocity, the concept that I give you something now, you give me something later. You need to assign value to objects based on their scarcity or usefulness. These are sophisticated cognitive skills. They require theory of mind, the ability to understand that other people have their own thoughts, desires, and motivations. They require long-term planning and memory. They require social institutions that can maintain relationships across time and distance. Your ancestors were building networks, not just family groups connected by kinship, but economic networks that linked disparate populations across hundreds of miles. These networks were the highways along which not just goods moved, but ideas, technologies, stories, genes. They were the infrastructure of emerging human culture. But then, 74,000 years ago, everything nearly ended, again. Mount Toba erupted. Not just erupted, exploded. This supervolcano in what is now Indonesia underwent one of the largest eruptions in the last 2 million years. It ejected an estimated 2,800 cubic kilometers of rock and ash into the atmosphere. For comparison, the 1980 eruption of Mount St. Helens ejected about 1 cubic kilometer. Toba was almost 3,000 times larger. The ash from this eruption spread across the entire planet. In India, there are places where Toba ash lies in layers several meters thick. In Africa, thousands of miles away, a layer of volcanic ash marks the moment when the sky turned dark. The environmental impact was catastrophic. Ash in the atmosphere blocks sunlight. Global temperatures may have dropped by 3 to 5 degrees Celsius. In some regions, the cooling could have been even more severe. This volcanic winter could have lasted for years, maybe decades. Photosynthesis slows down when there's less sunlight. Plants die. Animals that eat plants die. Predators that eat those animals die. Ecosystems collapse, and humans, scattered across Africa and just beginning to explore beyond, would have been hit hard. Genetic evidence suggests another population bottleneck around this time. Not as severe as the Great Bottleneck 900,000 years before, but significant. The effective breeding population of humans may have dropped to just a few thousand individuals worldwide. Think about what that means. All those networks your ancestors had been building, those trade routes, those relationships between distant groups, Many of them would have simply disappeared as populations crashed. Groups that had been flourishing in good territories suddenly found themselves starving as the climate shifted. Regions that had been marginal but survivable became completely uninhabitable. Some researchers think the Toba eruption nearly wiped out humanity. That for a few thousand years, our species teetered on the edge of extinction for the second time in our history. Others argue the impact was less severe, that human populations were resilient enough to weather even this catastrophe without coming as close to the brink. The truth is probably somewhere in between. Toba was devastating. Populations crashed. Entire regions were probably depopulated. But your ancestors had something their predecessors during the earlier bottleneck didn't have. Those emerging cognitive abilities. Symbolic thinking. Advanced tool technology. Social networks that could maintain information exchange even when populations were scattered and depleted. They survived. Barely, but they survived. And genetic analysis shows something remarkable. The populations that made it through Toba weren't just random survivors. They carried specific genetic variants that seemed to be favored during this crisis. Variants related to cognitive function, to immune response, to metabolic efficiency. Toba was another selection event, another filter, another moment when only the smartest, most adaptable, most cooperative humans made it through. Evolution was refining humanity, forging us in repeated catastrophes, selecting for the exact traits that would eventually let us dominate the planet. But your ancestors weren't just sitting in Africa waiting for the climate to improve. Some of them were exploring. Around 100,000 years ago, maybe even earlier, small groups started venturing out of Africa into the Middle East. The Levant, that narrow strip of coastline and hills connecting Africa to Asia, became a frontier zone where African humans encountered the descendants of earlier migrations, including Neanderthals who'd been living in the region for hundreds of thousands of years. These early attempts at colonization didn't go well. The archaeological record shows human presence in the Middle East appears and disappears multiple times. Groups move in, establish themselves for a few thousand years, then vanish from the fossil record. Were they wiped out by climate shifts? Outcompeted by Neanderthals who knew the territory better? Did they simply die out due to inbreeding in small isolated populations? We don't know. What we do know is that these attempts failed, repeatedly. For tens of thousands of years, modern humans tried to establish permanent populations outside Africa, and for tens of thousands of years they failed. The world beyond Africa was already occupied by successful, well-adapted human species. There was no easy ecological niche waiting for newcomers. But each attempt taught something. Each group that ventured into new territories learned lessons, developed new technologies, adapted to new challenges. And critically, some of those groups probably interbred with the humans they encountered. Genetic exchange happened. Ideas were shared. Technologies transferred between populations. By 70,000 years ago, the stage was set. Your ancestors had survived Toba. They had weathered another population crash. They had developed symbolic thinking, sophisticated tools, long-distance trade networks, and complex social structures. They had tested themselves against new environments and learned from their failures. They were ready for something that would change everything. They just didn't know it yet. Because somewhere in Africa, in the populations recovering from the Toba catastrophe, something was about to shift. Some combination of genetic changes and cultural innovations, maybe some random accident of history, was about to produce the most transformative event in human evolution since the chromosome fusion 900,000 years earlier. The cognitive revolution was coming, and when it arrived, nothing would ever be the same. Around 50,000 years ago, something extraordinary happened. And when I say extraordinary, I don't mean gradually interesting or incrementally noteworthy. I mean something so dramatic, so transformative, that archaeologists looking at the fossil record can see it like a lightning bolt frozen in stone. Before this moment, your ancestors had been anatomically modern humans for 150,000 years. They had the same brains, the same bodies, the same physical potential as you do right now. They'd survived the bottleneck, diversified across Africa, developed increasingly sophisticated tools and social structures. They were smart, capable, resourceful, but they weren't quite us yet. Then, in what amounts to an evolutionary eye blink, everything changed. The archaeological record literally explodes with innovation. New tools appear and spread across continents in mere thousands of years instead of hundreds of thousands. Art suddenly shows up everywhere. Cave paintings, carved figurines, decorated objects. Burial practices become elaborate and symbolic. Trade networks expand to move materials across distances that would have seemed impossible to earlier populations. It's so dramatic, so sudden, that archaeologists have given it a special name, the cognitive revolution. Some call it the Great Leap Forward. Others prefer the Upper Paleolithic revolution. But whatever you call it, one thing is clear. After 200,000 years of slow, steady development, something fundamental shifted in how humans thought, communicated, and organized themselves. The question that's haunted anthropologists for decades is simple. What the hell happened? Here's what makes this mystery so compelling. The evidence isn't ambiguous. It's not like we're looking at subtle changes that might or might not be significant. The transformation is blindingly obvious. You could take an archaeologist who knew nothing about dating techniques, show them artifacts from 60,000 years ago, and artifacts from 40,000 years ago, and they'd immediately tell you these had to come from different time periods, probably different species even, except they don't. They come from the same species, just separated by a few thousand years. So what caused this explosive change in human behavior? There are three main theories, and here's where things get really interesting. Each theory has compelling evidence, and each would require fundamentally different explanations for how and why we became truly modern humans. Theory 1. A genetic mutation changed everything. This is the dramatic, singular event explanation. Somewhere around 50,000 to 70,000 years ago, a small genetic change occurred in a single individual or a small group. Maybe it affected brain structure, neural connectivity, or the physical apparatus that allows for complex language. This mutation provided such massive advantages that it spread rapidly through the population. Within a few thousand years, everyone carrying this genetic variant had outcompeted or absorbed everyone who didn't. The appeal of this theory is its simplicity. One change, one explanation for everything that followed. And there's precedent for it. We know that small genetic changes can have enormous effects. The mutation that allowed adult humans to digest milk only happened about 10,000 years ago, but it transformed entire cultures and economies. A mutation affecting language or abstract thinking could have had even more profound impacts. The problem is we haven't found it. Despite sequencing ancient DNA from multiple periods and populations, nobody has identified a clear genetic change that appears right at this moment and could explain the behavioral revolution we see. Maybe it existed, and we just haven't recognized it yet. Maybe it affected brain organization in ways that don't leave obvious genetic signatures. Or maybe the answer lies elsewhere. Theory 2. The change was organizational, not genetic. This theory says your 50,000-year-old ancestors had the same cognitive hardware as humans from 150,000 years ago. Same genes, same brain structure, same potential. What changed wasn't biology but neurology, specifically how the brain was organized and how different regions communicated with each other. Think about it like this. You could give someone all the components of a computer, every chip and wire and circuit board, but if they're not connected properly, you don't get a working computer. The brain is similar. The same biological structures can be wired together in different ways, producing radically different capabilities. According to this theory, something changed in how human brains developed during childhood. Maybe it was cultural practices, new ways of interacting with children that encouraged particular neural pathways. Maybe it was environmental factors that affected brain development. Or maybe it was just accumulated experience, populations that had been practicing complex behaviors for so long that they literally rewired their children's brains through early learning. This would explain why the change seems sudden in the archaeological record but doesn't show up in genetics. The hardware didn't change, the software did. And crucially, this software upgrade could spread through populations not through reproduction, but through culture. Children raised in groups that practiced these new cognitive patterns would develop the same patterns, regardless of their genetic heritage. The evidence supporting this comes from modern neuroscience. We know that brain organization is highly plastic, especially during childhood. We know that different cultures literally wire brains differently. Modern brain scans show that literate people process language differently than illiterate people from the same population. Learning to read physically reorganizes your brain. If something as recent as literacy can do that, imagine what innovations in language, tool use, and social interaction might have done to our ancestors' developing brains. Theory 3, and this is the one I find most compelling. Cultural accumulation reached critical mass. This theory says nothing sudden happened at all, not genetically, not neurologically. What happened was that human cultures had been slowly accumulating knowledge, skills, and innovations for hundreds of thousands of years. For most of that time, the process was slow, easily disrupted by disasters that could wipe out entire groups and their accumulated knowledge. But by 50,000 years ago, populations had grown large enough and networks had become robust enough that knowledge stopped getting lost. Each generation could build on what came before instead of having to rediscover basic survival techniques. This created a positive feedback loop. More people meant more innovations meant better survival meant more people. Round and round, accelerating faster and faster until the rate of cultural change exploded. Under this model, there was no moment when humans suddenly became capable of modern behavior. Instead, there was a long, slow accumulation of capabilities that finally reached a threshold where cultural evolution could sustain itself and accelerate. Like a fire that's been smouldering for hours suddenly getting enough oxygen to burst into flames. The evidence for this theory comes from looking at human populations that remained isolated into recent times. Groups in Tasmania, separated from mainland Australia by rising seas, actually lost technologies over thousands of years. They forgot how to make bone tools, how to catch fish, how to create cold weather clothing. Not because they became less intelligent, but because their populations were too small to maintain the accumulated knowledge. This suggests that cultural complexity requires minimum population sizes and network connections to sustain itself. Similarly, the rapid innovation we see after 50,000 years ago corresponds exactly with evidence of population growth and expanding trade networks. More people, more connections, more innovation. It's not about individuals suddenly getting smarter. It's about societies reaching the size and complexity where they could maintain and build on accumulated knowledge. So which theory is right? Here's the frustrating answer. Probably all of them, to some degree. The archaeological evidence shows the transformation was real and dramatic. Between 50,000 and 40,000 years ago, human culture changed more than it had in the previous 150,000 years. Let's look at what actually appeared in the archaeological record, because this is where theory meets reality. Tool technology underwent a revolution. For hundreds of thousands of years, human stone tools had been improving, but slowly. Techniques developed in Africa might take 50,000 years to spread to Europe. New tool types appeared maybe once every 10,000 years. Then suddenly, boom! Blade technology appears and spreads across continents in a few thousand years. Instead of making simple hand axes by chipping away at rocks, humans learned to create prismatic cores from which they could strike off dozens of long, thin, sharp blades. These blades were lighter, more efficient, and could be produced in standardized sizes for specific purposes, but it gets better. Within just a few thousand years, those basic blades were being modified into specialized tools, burins for engraving, backed blades for composite tools, microliths that could be hafted together to create sophisticated cutting implements. Your ancestors were basically developing a standardized toolkit with interchangeable parts, 45,000 years before the Industrial Revolution supposedly invented that concept. And the innovation didn't stop. New technologies appeared and spread at accelerating rates. Atlatls, spear throwers that doubled the range and power of thrown projectiles, nets and snares for catching small game and fish, grinding stones for processing plant foods, needles with your eyes for sewing fitted clothing. Each innovation built on what came before, and each appeared faster than the last. This wasn't gradual evolution anymore. This was revolution. Then there's the art. Oh, the art. This is what really blows archaeologists' minds, because art is unambiguous evidence of symbolic thinking, of abstract reasoning, of the ability to imagine things that don't exist, and then make them real. The first cave paintings appear around 45,000 years ago in Indonesia, shortly after in Europe. And these aren't crude stick figures. These are sophisticated, beautiful representations of animals rendered with attention to anatomy, movement, and proportion. The horses gallop, the bison charge, the lions hunt. Your ancestors weren't just documenting what they saw. They were capturing essence, movement, life itself. But paintings are just the beginning. Carved figurines start appearing everywhere. The famous Venus figurines, stylized representations of women with exaggerated features, show up from Spain to Siberia. Some are realistic, others highly abstract, but all demonstrate the ability to conceive of and execute complex three-dimensional forms. Musical instruments appear in the archaeological record. Bone flutes with carefully drilled holes tuned to specific pitches. Percussion instruments made from hollow logs or stretched hides. Your ancestors weren't just surviving anymore. They were creating beauty, making music, expressing something that went beyond mere utility. Personal ornaments explode across the archaeological record. Beads made from shells, bones, and stones, often transported hundreds of miles from their source. Necklaces, bracelets, pendants, each one carefully crafted, often requiring hours of work to drill tiny holes or polish surfaces smooth. Why would anyone spend hours making a bead unless it meant something beyond its physical form? These ornaments were symbols. They communicated identity, status, group affiliation. They were language made visible, social meaning carved into matter. The burial practices from this period tell an even more profound story. Earlier humans had occasionally buried their dead, but the practice was inconsistent. After 50,000 years ago, burial becomes elaborate, systematic, and deeply symbolic. Bodies are positioned carefully, often in specific orientations. They're buried with grave goods, tools they might need in another life, ornaments they wore in this one. Some graves show evidence of being reopened and revisited, suggesting ongoing relationships with the dead. At Sungir in Russia, a site dating to about 34,000 years ago, archaeologists found children buried in clothing decorated with thousands of ivory beads. The time required to make those beads would have been enormous, suggesting a massive investment of community resources in honouring the dead. This isn't just practical disposal of bodies. This is evidence of complex beliefs about death, possibly about an afterlife, certainly about the significance of individual humans as beings worthy of remembrance and honour. Your ancestors were grappling with mortality, creating meaning in the face of death, doing all the things we still do today. But perhaps the most revolutionary change was in how humans hunted and gathered food. Earlier populations had been competent hunters, capable of taking down large animals occasionally. After 50,000 years ago, hunting becomes systematic, strategic, and devastatingly effective. Projectile weapons appear, allowing hunters to kill from a distance without risking close combat with dangerous prey. Atlatls could send a spear 100 yards with enough force to penetrate thick hide. Eventually, bows and arrows would make ranged hunting even more effective. But weapons were just part of the revolution. Archaeological evidence shows organized game drives, where dozens of hunters would coordinate to stampede entire herds over cliffs or into natural traps. Kill sites show evidence of systematic butchering, with different body parts processed for different purposes. Meat, hides, bones, sinew, all used efficiently. Fishing becomes systematic too. Nets, hooks, and traps appear in the archaeological record. Coastal populations begin exploiting marine resources intensively. Your ancestors were diversifying their diet, reducing their dependence on any single food source, building resilience into their subsistence strategies. Most importantly, all this evidence points to something that doesn't fossilize directly, but whose effects are unmistakable. Fully modern language. Simple communication could explain tool use. Even alarm calls and basic gestures could coordinate simple hunts. But the innovations appearing after 50,000 years ago require something more. They require the ability to plan across time, to discuss abstract concepts, to share detailed information about techniques and technologies. You can't teach someone to make a composite tool with hand gestures. You can't coordinate a game drive involving dozens of people without detailed planning. You can't maintain trade networks spanning hundreds of miles without the ability to negotiate, promise, and remember obligations. And you certainly can't create art without the capacity for symbolic thought, the ability to say, this represents that, to make one thing stand for another. Language, complex grammatical language capable of expressing abstract relationships and temporal concepts, had to exist. Not just vocabulary, but syntax. Not just labels for things, but the ability to talk about things that weren't present, things that hadn't happened yet, things that existed only in imagination. This is what separates us from every other species. Plenty of animals use tools. Some even make art of a sort. Many have complex social structures. But only humans have language that lets us share thoughts, transmit culture, build on accumulated knowledge across countless generations. And somewhere around 50,000 years ago, that capacity either emerged or reached maturity, or became universal enough that its effects dominate the archaeological record. The debate about whether this was gradual or sudden, genetic or cultural, continues. But what's not debatable is that something fundamental changed. The humans living 40,000 years ago were recognizably us in ways that humans from 100,000 years ago weren't. They created beauty for its own sake. They honored their dead. They told stories around fires. They decorated their bodies and their possessions. They imagined futures and made plans to achieve them. They were capable of the full range of human thought and feeling. They were, finally and fully, modern humans, and they were about to change the world forever. So there they stood, a small group of modern humans on the shores of the Red Sea, looking across at the Arabian Peninsula. They had no idea they were about to change the world. They were just looking for food, for new territory, for a better life than the one they'd known in Africa. Maybe the crossing was easy that year. Sea levels were lower during glacial periods, and the waters separating Africa from Arabia would have been narrower, maybe just a few miles of shallow straits instead of the broader channels we see today. Perhaps they built rafts from bundled reeds, or maybe they simply waded across during low tide, carrying children on their shoulders, tools wrapped in animal skins to keep them dry. However it happened, sometime around 70,000 years ago, a few hundred modern humans successfully left Africa and survived long enough to establish breeding populations in Asia. And this time, unlike previous attempts that had failed or fizzled out, this time it worked. Within just 30,000 years, their descendants would spread to every corner of the planet except Antarctica. They would encounter and outlast every other human species on Earth. They would adapt to environments ranging from tropical rainforest to Arctic tundra. They would become us. But that first crossing, that was just the beginning. The route they took is still debated by archaeologists, but the most compelling evidence points to what's called the coastal route hypothesis. Instead of trudging through the harsh deserts of the Arabian interior, these early migrants stuck to the coastlines. Think about why that makes sense. Coastlines are basically long buffets of resources. You've got fish and shellfish in the water, birds and their eggs on the shore, freshwater streams flowing down to the sea, plants growing wherever fresh water meets salt. A group of humans following a coastline doesn't need to develop completely new survival strategies. They can use variations of skills they already know: fishing, foraging, hunting small game, while gradually adapting to new environments. The archaeological evidence backs this up. We find early modern human sites along ancient coastlines, from the Red Sea through southern Arabia, along the coast of India, through Southeast Asia, and all the way to Australia. These aren't random dots on a map. They're breadcrumbs marking an epic journey that covered more than 8,000 miles. And they made that journey fast. Genetic evidence suggests the expansion from Africa to Southeast Asia took only a few thousand years. That's remarkable. These weren't nomads wandering aimlessly. This was directed migration, groups deliberately moving into new territories, establishing settlements, then sending out pioneers to explore even further. Some groups would stay in favourable locations for generations. Others would keep pushing forward, driven by population pressure, curiosity, or the simple human urge to see what's over the next hill. But here's where the story gets absolutely wild. By 65,000 years ago, maybe earlier, Modern humans had reached Australia. Let that sink in. Australia. To get there from mainland Southeast Asia required crossing at least 60 miles of open ocean. There's no land bridge, never has been, even during the lowest sea levels of the Ice Ages. This means those early humans didn't just have boats. They had seaworthy boats capable of carrying families, supplies, and tools across dozens of miles of ocean. They had navigation skills, the ability to read stars, currents, and weather patterns. They had planning abilities, the capacity to organize expeditions into unknown territory, with no guarantee of finding land on the other side. This is sophisticated technology. This is complex social organization. This is cognitive capability that rivals anything we do today. Imagine being part of that first voyage. You're standing in a wooden boat, probably an outrigger canoe or raft of bundled logs, surrounded by your family and everything you own. Behind you, the coastline of Southeast Asia fades into the distance. Ahead, nothing but ocean as far as you can see. You don't know if there's land out there. You're trusting your life to knowledge passed down from ancestors who claim they'd seen smoke or birds in the distance, signs that maybe, possibly, there's something worth finding beyond the horizon. And you keep paddling. For hours, maybe days. Children crying, water running low, everyone wondering if this was a terrible mistake. Then finally someone spots it. A dark line on the horizon that slowly resolves into cliffs, beaches, forests. Land. New land. You've just discovered a continent. Once in Australia, these pioneers found themselves in a world unlike anything their African ancestors had ever encountered. Marsupials instead of placental mammals, birds and reptiles of bizarre shapes and sizes, plants with no equivalents anywhere else on Earth. They adapted fast. Within a few thousand years, they'd spread across the entire continent from the tropical north to the temperate south, from the wet coastal regions to the arid interior. They developed new hunting techniques for animals that behaved differently than African game. They learned which Australian plants were edible and which were deadly. They created tools and weapons suited to local materials. Most remarkably, they maintained this knowledge and passed it down through hundreds of generations. Modern Aboriginal Australians can trace their ancestry back to these first arrivals, making theirs one of the longest continuous cultures in human history. But while some humans were sailing to Australia, others were taking a different path. They were heading north and west, into territories that has been controlled by Neanderthals for hundreds of thousands of years. The meeting between modern humans and Neanderthals, sometime between 60,000 and 50,000 years ago, in the Middle East and Europe, this wasn't first contact. The two species had probably encountered each other before during earlier, failed expansions out of Africa. But this time was different. This time, modern humans were coming with superior numbers, better technology, and perhaps most importantly, more flexible social structures. The encounters weren't always hostile. We know this because of what the genetic evidence tells us. Modern humans and Neanderthals interbred, not just once or twice, but repeatedly over thousands of years. Today, if you have ancestry from outside Africa, roughly 1 to 2% of your DNA comes from Neanderthals. That's not a tiny amount. That's hundreds of genes, many of them still functional, still affecting how your body works today. Some Neanderthal genes help modern humans fight off diseases. Others affect skin color and hair texture, adaptations that proved useful in northern climates. Still others influence how our immune systems respond to threats. The Neanderthals might be extinct as a distinct species, but they live on in us, their DNA woven into the human genome. But what were these encounters actually like? Picture a Neanderthal hunting party, tracking deer through a European valley they've known for generations. They hear unfamiliar sounds, voices speaking a language they don't recognize. They see smoke from cooking fires, smell the scent of grilled meat. They approach cautiously and find a group of strangers. These newcomers look different, more graceful, less robust, with different facial features. They have tools the Neanderthals don't recognize, decorations and ornaments that seem to serve no practical purpose, ways of organizing their camps that are alien and strange. Maybe the first meeting is tense. Weapons are displayed, threats are made. Or maybe it's more diplomatic. Trade is attempted, gifts are exchanged. Perhaps over time the groups learn to coexist, hunting in different areas, avoiding direct competition, and eventually, inevitably, young people from both groups are attracted to each other. Relationships form, children are born who carry genes from both populations. But these peaceful interactions couldn't last forever. As modern human populations grew, they needed more territory, more resources. The archaeological record shows that wherever modern humans arrived in significant numbers, Neanderthal populations declined within a few thousand years. We don't know if this was violent conquest, whether modern humans actively hunted Neanderthals to extinction. More likely it was competition. Modern humans were simply better at exploiting available resources. They had more sophisticated social networks that let them coordinate hunts over larger territories. They had better long-range weapons like spear throwers that could kill prey from a safe distance. They had more diverse diets, capable of eating a wider range of foods when preferred resources became scarce. In a fair fight, Neanderthals probably would have won. They were stronger, more robust, better adapted to the cold. But evolution isn't a fair fight. It's about reproductive success, and modern humans were having more children, spreading faster, adapting more quickly to changing conditions. By 40,000 years ago, Neanderthals were restricted to a few isolated refugees in southern Europe. Within another 10,000 years, they would be completely gone. Further east, modern humans encountered a different group of archaic humans, the Denisovans. We know even less about the physical meetings between modern humans and Denisovans because the archaeological evidence is so sparse. But the genetic evidence is unambiguous. Modern humans and Denisovans interbred extensively, probably in multiple locations across Asia over thousands of years. Today, people with ancestry from Papua New Guinea carry up to 5% Denisovan DNA, far more than the Neanderthal contribution in Europeans. Other Asian populations carry smaller but significant amounts. These genes weren't just genetic noise, they provided real survival advantages. The Denisovan gene variant that helps Tibetans process oxygen efficiently at high altitudes, that's not a coincidence. That's natural selection preserving a useful adaptation inherited from an extinct species. Modern humans settling in the Himalayas faced a serious problem. The thin air made normal oxygen processing insufficient. Those who inherited the Denisovan high-altitude genes had a massive advantage. They could work harder, hunt more effectively, have healthier children. Over generations, that gene spread through the population until it became standard. The Denisovans also contributed genes that help modern humans survive in cold climates, process different types of food, and resist certain diseases. Like the Neanderthals, they disappeared as distinct species but live on in the DNA of modern populations. Think about what this means. Modern humans didn't just replace other human species, we absorbed them. We took their genes, their adaptations, their evolutionary solutions to environmental challenges, and made them part of ourselves. Every person alive today with ancestry from outside Africa is a hybrid, carrying DNA from multiple human species. But modern humans weren't just incorporating genes from other species. They were adapting to environments more diverse than any single species had ever encountered. The descendants of those African migrants were now living in tropical rainforests in Southeast Asia, temperate woodlands in Europe, the harsh deserts of Australia's interior, and eventually the frozen tundra near the Arctic Circle. Each environment demanded different survival strategies. Tropical populations needed to deal with constant heat, humidity, and disease pressure from parasites and pathogens that thrived in warm conditions. They developed darker skin to protect against intense UV radiation, adapted their immune systems to fight off tropical diseases, learned to exploit forest resources that were abundant but required specialized knowledge to use safely. Arctic populations faced opposite challenges: extreme cold, months of darkness, scarce plant foods for most of the year. They developed lighter skin to maximize vitamin D production during brief periods of sunlight, stockier builds to conserve heat, entirely carnivorous diets based on hunting marine mammals and migrating caribou. And they did all this in just a few thousand years. That's not enough time for massive genetic changes, though some did occur. Most of the adaptation was cultural, learning to make warm clothing from animal skins, developing sophisticated hunting technologies, creating social systems that could maintain crucial knowledge through long, dark winters when mistakes could be fatal. By 40,000 years ago, modern humans had established themselves across 3 continents. They'd encountered and absorbed 2 other human species. They'd developed the sailing technology to cross oceans and the cold weather adaptations to survive near the Arctic. They'd gone from a small African population to a global species in just 30,000 years, and they were just getting started. Because the really spectacular innovations, the explosion of art, technology, and culture that would transform them into the undisputed masters of Earth, that was about to begin. The stage was set, the cast was in place, and humanity was about to become something the world had never seen before. So your ancestors have spread across the globe. They've survived ice ages, crossed impossible distances, encountered other human species. By 40,000 years ago, modern humans have established populations across Africa, the Middle East, Asia, and Australia. Small groups are pushing into Europe, encountering the Neanderthals who had been there for hundreds of thousands of years. And then something extraordinary happens. Between 40,000 and 20,000 years ago, human culture explodes. Not gradually, not slowly over millions of years like the stone tools that came before, but rapidly, dramatically, in ways that would have seemed absolutely impossible to the humans who lived just 10,000 years earlier. Archaeologists call this the Upper Paleolithic Revolution, and revolution is not an exaggeration. This is the period when humans stop being just another clever primate and start becoming something unprecedented in the history of life on Earth. This is when we start creating beauty for its own sake, when we start contemplating mysteries beyond survival, when we start building the foundations of art, music, spirituality, and social complexity. Let's start with what's happening in Europe, because that's where we have the most evidence. Around 40,000 years ago, modern humans arriving in Europe bring with them something called the Aurignacian culture. Not just new stone tools, though those are impressive enough, but an entire package of technologies, artistic practices, and social systems that are unlike anything that came before. The tools themselves represent a quantum leap. These aren't crude choppers or simple spear points. These are standardized, specialized implements designed for specific tasks. Long, thin stone blades that could be used as knives or mounted on handles. Carefully crafted scrapers for preparing hides. Burins, basically ancient chisels designed specifically for working other materials. Because here's what's really revolutionary. Humans are no longer just making tools from stone. They're using stone tools to make tools from other materials. Bone, antler, ivory from mammoth tusks, wood that's been seasoned and shaped. They're creating a secondary tier of technology, using one set of tools to manufacture another. The sophistication is stunning. Bone needles with eyes threaded through them. Not simple bone awls that you push through hide, but actual needles that could sew fitted clothing. This might not sound impressive until you realize what it enabled. With sewn clothing, humans could survive in environments that would have killed them before. The coldest regions of Ice Age Europe became habitable, the far north of Asia. Eventually, the frozen landscapes of the Americas, harpoons carved from antler, with barbed points designed to lodge in fish or seals, attached to lines so prey couldn't escape. This is engineering. This is humans sitting down and thinking through problems systematically, designing solutions, testing them, refining them across generations. Spear throwers called atlatls that could multiply the force of a human arm several times over. A hunter with an atlatl could bring down prey from distances that would have been impossible before. This changed everything about hunting strategy, about social organization, about which humans survived and which didn't. But the tools, as impressive as they are, aren't even the most remarkable part. Because this is also when humans start creating things that have absolutely no survival value whatsoever. Things that exist purely to be beautiful, to communicate meaning, to express something beyond the immediate need for food and shelter. The cave paintings. In 1994, 3 French explorers discovered something that changed our understanding of ancient humans forever. The Chauvet Cave in southern France. When they squeezed through a narrow passage and shined their lights into a hidden chamber, they found themselves staring at the most sophisticated prehistoric art ever discovered. Lions, horses, rhinoceroses, dozens of animals rendered with such skill, such understanding of anatomy and perspective, that they could have been painted yesterday, except they weren't. Radiocarbon dating put the paintings at 36,000 years old. Let that sink in. 36,000 years ago, humans were creating masterpiece-level art in pitch-black caves, using charcoal and ochre and manganese oxide, mixing pigments with animal fat to create paints that would last for millennia. They were applying shading techniques to suggest three-dimensional form. They were using the natural contours of the cave walls to add depth and movement to their subjects. They were painting animals in ways that captured not just their appearance but their essence, their motion, their spirit. And Chauvet isn't unique. Lascaux Cave, Altamira Cave, dozens of sites across Europe, all showing the same incredible sophistication, the same artistic vision. Some sites show evidence of scaffolding, meaning artists built platforms to reach high walls and ceilings. They're planning these compositions, choosing specific locations for specific reasons. But why? Why would Ice Age hunters, people whose every day was a struggle to find food and stay alive, spend hours, maybe days, deep in dark caves, creating images that nobody might ever see again? This is where archaeology meets mystery. Some researchers think the caves were sites of shamanic rituals, places where spiritual leaders would go to contact the spirit world, to ensure successful hunts, to maintain the relationship between humans and the animals they depended on. The placement of the paintings supports this. They're not in the comfortable inhabited parts of caves. They're deep inside, in chambers that required dangerous climbs through narrow passages. These were special places, sacred places, places set apart from daily life. Others think the caves were teaching sites, where elders would bring young people to instruct them in hunting techniques, animal behavior, the crucial knowledge needed to survive. The paintings would serve as textbooks, visual references for lessons about the natural world. Or maybe they were simply expressions of human consciousness becoming aware of itself. The moment when our ancestors looked at the world and felt compelled not just to survive in it, but to reflect it back, to say, I was here, I saw this, I understood this. Whatever the purpose, the caves prove something profound. By 35,000 years ago, humans possessed symbolic thinking sophisticated enough to create complex art. They could conceive of representing three-dimensional reality on two-dimensional surfaces. They could imagine audiences beyond themselves, creating works that would communicate across time and space. They had crossed the threshold from beings who merely lived in the world to beings who contemplated the world, who created meaning beyond survival. And they were creating other kinds of art too. The Venus figurines, small carved statues of women found across Europe, from Spain to Siberia, dating between 35,000 and 20,000 years ago. The Venus of Willendorf, the Venus of Dolny Vestonich. Dozens of examples, all showing similar characteristics: exaggerated breasts and hips, minimal facial features, bodies that seem to celebrate fertility, abundance, the power of women to create life. What do they mean? Nobody knows for sure. Fertility goddesses, as many researchers have suggested, representations of actual women in the community, pregnant women creating self-portraits, teaching tools about pregnancy and childbirth, or maybe ancient pornography, though that seems unlikely given the care and skill involved in creating them. What we do know is that people were making them across thousands of miles and thousands of years, suggesting shared symbolic meaning. This is culture spreading, ideas moving faster than genes. Humans in what is now Austria and humans in what is now Russia, participating in the same artistic tradition, even though they probably never met. They were making music too. Bone flutes carved from bird bones and mammoth ivory, with carefully drilled holes positioned to produce specific notes. These aren't crude noisemakers. These are actual musical instruments capable of playing melodies. The oldest, found in Holy Fels Cave in Germany, is 40,000 years old and could still produce music if someone knew how to play it. Think about what this means. Someone in Ice Age Europe spent hours, maybe days, carefully selecting a bone, drilling precise holes, testing the sound, refining it until it worked. Why? Because humans wanted music. Because we had developed aesthetic sense, the ability to appreciate sound organized into patterns. Because we had become creatures who needed more than survival, who needed beauty, expression, art, and we were becoming more socially complex. The archaeological record from this period shows the first clear evidence of status differentiation. Elaborate burials where certain individuals are buried with dozens of carefully crafted grave goods, shell beads, carved ivory, the best tools. Others are buried with nothing. This suggests some people held special positions in their communities. Leaders, shamans, master craftspeople. Society was becoming stratified. Long-distance trade networks were forming that spanned hundreds of kilometers. Shells from the Mediterranean show up in deep Central Europe. Amber from the Baltic appears in graves far inland. Obsidian, volcanic glass prized for tool-making, travels hundreds of miles from source to user. This requires trust, reciprocity, complex social relationships maintained across distances and generations. People were specializing. Not everyone needed to be a hunter anymore. Some individuals could focus on tool-making, becoming master craftspeople whose products were traded widely. Others specialized in hide preparation, bone carving, bead making. The evidence suggests some communities were producing far more of certain items than they needed. Clear indication of production for trade. This is the foundation of economic complexity. Division of labor, specialization, exchange relationships that transcend immediate kinship groups. Your ancestors were building the social systems that would eventually give rise to cities, kingdoms, civilizations. But perhaps most remarkably, they were contemplating mysteries beyond the material world. The elaborate burials aren't just about status. They show evidence of ritual, of belief in something beyond death. Bodies carefully positioned, grave goods suggesting belief in an afterlife where the dead would need tools and ornaments, red ochre sprinkled on corpses, possibly symbolizing blood, life, rebirth. The cave paintings show this too. Not just representations of animals, but strange hybrid creatures, part human, part beast. Handprints stenciled on walls as if saying, "I existed, I touched this place." Geometric patterns that might represent altered states of consciousness, shamanic visions, spiritual experiences. By 20,000 years ago, humans weren't just surviving anymore. We were creating, we were innovating, we were building complex societies with art, music, spiritual beliefs, and social hierarchies. We were trading across vast distances, maintaining relationships with people we might never meet. We were contemplating existence itself, creating meaning beyond the immediate struggle for survival. We'd become fully modern in every way that matters. The hardware had been in place for 100,000 years, but now the software was finally running at full capacity. The cognitive revolution that began at 50,000 years ago had reached its full flowering, and we were just getting started. By 20,000 years ago, your ancestors had already accomplished something extraordinary. They'd survived the genetic bottleneck. They'd developed language, art, sophisticated tools. They'd spread across Africa, Europe, and Asia, adapting to environments from tropical rainforest to frozen tundra. But they were about to face their greatest challenge yet. Not a climate disaster this time, but something almost as daunting: the last glacial maximum, the absolute peak of the Ice Age, when ice sheets covered a third of the planet and global temperatures dropped to their lowest point in over 100,000 years. Here's what made this different from earlier climate crises. Your ancestors weren't just trying to survive anymore, they were thriving. While ice sheets a mile thick crushed northern Europe and North America, human populations didn't collapse. They didn't retreat to a handful of refugees and wait it out. Instead, they adapted, innovated, and somehow continued to spread into territories that should have been completely uninhabitable. Think about what 20,000 years ago actually looked like. Sea levels had dropped 400 feet because so much water was locked up in ice. Coastlines extended miles beyond where they are today. Entire land bridges emerged, connecting continents that are separated by water now. The Bering land bridge between Siberia and Alaska wasn't some narrow strip you could cross in an afternoon. It was a subcontinent, hundreds of miles wide, a vast grassland ecosystem called Beringia that supported mammoths, horses, bison, and the human hunters who followed them. And your ancestors were living there, not just passing through, actually living in some of the harshest conditions humans had ever faced. We're talking about winters where temperatures regularly dropped to -40, where the sun barely rose for months at a time, where a single mistake in clothing or shelter construction could mean death within hours, but they'd figured it out. Archaeological sites from Siberia show sophisticated cold weather adaptations that would have impressed modern Arctic explorers. They built semi-subterranean houses, digging deep into the permafrost for insulation, then constructing frameworks from mammoth bones and covering them with thick layers of animal hides. Some of these structures used the bones of dozens of mammoths, representing years of hunting success and engineering knowledge passed down through generations. They developed fitted clothing, not the simple wraps and cloaks their ancestors had worn in warmer climates, but carefully tailored garments with sleeves, hoods, and probably primitive buttons or toggles. We know this because the stone tools they left behind include specialized hide scrapers and precise cutting implements designed for detailed leather work. They were making parkas 20,000 years before Canada Goose existed. Most impressively, they maintained trade networks across thousands of miles despite the brutal conditions. Archaeological sites in Siberia contain obsidian from sources hundreds of miles away, marine shells from distant coasts, amber from regions they could only have reached through elaborate exchange systems. This tells us they weren't isolated families barely clinging to survival. They were connected communities, sharing resources, ideas, and probably stories around fires during those endless Arctic nights. And then they kept going. Sometime between 20,000 and 15,000 years ago, these cold-adapted populations began moving east, across Beringia into Alaska, and from there into the Americas. The exact timing is hotly debated. Some evidence suggests humans reached Alaska by 20,000 years ago. Other data points to 16,000 or 15,000. The dates keep shifting as new sites are discovered and new dating techniques are developed. But here's what's not debated. However and whenever they arrived, what happened next was one of the most rapid expansions in human history. Within just a few thousand years, maybe as few as 2,000, human populations had spread from Alaska to Tierra del Fuego, the southern tip of South America. That's over 10,000 miles as the crow flies, much farther by foot, through every conceivable type of environment. Tundra, temperate forests, deserts, tropical jungles, high mountain ranges and wind-swept grasslands. To put that in perspective, it took humans over 200,000 years to spread out of Africa. It took maybe 2,000 to colonize 2 entire continents. This wasn't slow demographic expansion. This was explosive, purposeful migration by populations who had become expert at adapting to new environments quickly. The archaeological evidence shows up like breadcrumbs across the Americas. Distinctive stone tools called Clovis points appear suddenly around 13,000 years ago, from the Great Plains to the Gulf of Mexico. Similar technologies show up in Central America shortly after, then South America. By 12,500 years ago, humans had reached Monteverde in Chile, over 10,000 miles from Beringia. By 12,000 years ago, they'd reached the very tip of Patagonia. But they didn't just pass through these places, they adapted to each one, developing specialized technologies and survival strategies for every environment they encountered. In the Great Plains, they became expert mammoth hunters, developing techniques to take down animals weighing 6 tons. Archaeological sites show evidence of sophisticated hunting strategies, driving herds toward cliffs or box canyons, using the landscape itself as a weapon. In the Pacific Northwest, coastal populations developed maritime technologies, building boats, fishing with nets and hooks, harvesting shellfish and sea mammals. These weren't occasional fishing trips. These were societies whose entire economy revolved around the ocean, who could navigate treacherous coastlines and knew the behavior of seals, sea lions, and whales. In the Amazon, populations learned to thrive in what might be the most challenging environment on the planet for human survival. Dense jungle that limited visibility and movement. Soils so poor that conventional agriculture was almost impossible. Yet they figured it out, developing ways to process toxic plants into safe foods, cultivating crops in complex garden systems, using the river networks as highways through the forest. In the high Andes, people adapted to altitudes over 14,000 feet, where oxygen levels are half what they are at sea level. They developed enhanced lung capacity and more efficient oxygen processing, genetic adaptations we can still detect in modern Andean populations, and they did it in just a few thousand years, evolutionary change happening at breakneck speed because the selection pressures were so intense. But while humans were conquering these new territories, something else was happening, something tragic and still controversial. The megafauna were dying. When humans first entered the Americas, the continents were home to creatures that would seem like fantasy today. Mammoths and mastodons weighing up to 12 tons, ground sloths as large as modern elephants, saber-toothed cats, dire wolves, giant short-faced bears that stood 12 feet tall, glyptodonts, armored animals the size of cars, camels, horses, cheetahs, all native to the Americas before they went extinct, and within a few thousand years of human arrival, they were gone. Not some of them, nearly all of them. About 80% of North American megafauna species weighing over 100 pounds went extinct between 13,000 and 11,000 years ago. South America lost even more, maybe 90% of its large mammals. The debate over why this happened has raged for decades. Some researchers point to climate change. The Ice Age was ending, environments were shifting rapidly, animals adapted to cold grasslands suddenly found themselves in forests or deserts. But here's the problem with the climate explanation. These animals had survived previous warming periods. The Ice Age had cycled through dozens of warm and cold phases over hundreds of thousands of years, and the megafauna had made it through all of them. Why did they suddenly go extinct this time? The other explanation is blunt and uncomfortable. Humans hunted them to extinction. Not through some systematic extermination campaign, just through normal hunting by populations that were growing rapidly and had developed incredibly effective killing technologies. Those Clovis points weren't just sharp rocks. They were precision weapons that could penetrate deep into large animals, causing massive internal bleeding. Combined with coordinated group hunting tactics, humans had become the most effective predators these animals had ever encountered. And unlike the predators the megafauna had evolved alongside, humans were new. The animals had no instinctive fear of these strange upright creatures. By the time they learned to be wary, populations had already been decimated. Mathematical models show that even low levels of hunting combined with the slow reproduction rates of large mammals could drive species to extinction within centuries. The truth is probably some combination. Climate change stressed animal populations, shrinking their habitats and reducing their numbers. Then human hunting delivered the final blow, pushing species that might have recovered from climate stress into permanent extinction. Whatever the exact mechanism, the result was clear. Within 2,000 years of human arrival, the American megafauna was gone, and humans were the dominant large animals on 2 continents. Meanwhile, back in the Old World, Similar adaptations were happening. In the Arctic, populations were developing specialized technologies for hunting seals and fishing through ice. In the deserts of Australia, Aboriginal populations were refining the most sophisticated knowledge system of any hunter-gatherer society, learning to find water in landscapes that appeared completely barren, tracking animals across hundreds of miles, using controlled burns to manage entire ecosystems. In the highlands of New Guinea and Ethiopia, people were adapting to extreme altitudes, developing genetic variants that helped them process oxygen more efficiently. In the Congo rainforest, populations were learning to hunt forest elephants and harvest the incredible diversity of plants the jungle provided. Everywhere humans went, they adapted. Not over hundreds of thousands of years, but over thousands, sometimes just centuries. This wasn't the slow crawl of biological evolution anymore. This was cultural evolution running at full speed, knowledge and technology spreading faster than genes ever could. By 12,000 years ago, humans had established permanent populations on every continent except Antarctica. Not just surviving in these places, thriving, growing, diversifying. The global human population had probably reached several million, spread across environments ranging from Arctic tundra to tropical islands, from mile-high mountain plateaus to desert oases, and in each region, distinctive cultures were emerging. Different tool technologies, different hunting strategies, different art styles, different social structures. The genetic unity created by the bottleneck was still there. Humans everywhere were fundamentally the same species, but culturally, humanity was diversifying into thousands of distinct traditions, each perfectly adapted to its local environment and challenges. Your ancestors had conquered the world. Now they were about to transform it completely, because the next innovation wasn't about adapting to the environment anymore. It was about controlling it. By 12,000 years ago, humans had conquered the planet. We'd survived ice ages, crossed oceans, reached every continent except Antarctica. We'd outlasted the Neanderthals, absorbed the Denisovans, become the last human species standing. Our ancestors had developed art, music, sophisticated hunting techniques, complex social structures. They'd invented the atlatl, the bow and arrow, sewing needles, oil lamps. They were masters of their environment. And then the world tried to kill them. Again. Around 12,900 years ago, just as humans were getting comfortable, just as populations were growing and life was becoming relatively stable, the climate went haywire. We call it the Younger Dryas, and it was the last major climate crisis our ancestors would face before the modern era. Within a few decades, maybe faster, temperatures plummeted. In some regions, the drop was as much as 15 degrees Celsius. Glaciers that had been retreating for thousands of years suddenly surged forward again. Forests died back. Megafauna populations crashed. The great herds of mammoth, mastodon, and giant bison that humans had been hunting for millennia began disappearing. For about 1,300 years, the world was locked in this mini ice age. And here's where you see the difference between the humans of 12,000 years ago and the humans who'd faced earlier climate crises. They didn't just survive, they innovated their way through it. Because by this point, your ancestors had something their distant forebears didn't have. They had 50,000 years of accumulated knowledge. They had the cognitive tools that had been unleashed during the Great Revolution. They had languages capable of transmitting complex information across generations. They had social networks spanning hundreds of miles. They had the ability to look at a problem and invent entirely new solutions, and they needed all of it. In the Levant, the Eastern Mediterranean, groups of people called the Natufians faced a crisis. They'd been living in relatively permanent settlements, some of the first in human history. They'd been harvesting wild grains, wheat and barley that grew abundantly in the region. But the younger Dryas was killing those grasslands. The wild cereals were disappearing. The game animals were becoming scarce. They had a choice. They could abandon their settlements and go back to full nomadic life, or they could do something no human had ever systematically done before. They could try to control their food supply directly. Some groups did go back to nomadism, but others started experimenting. They noticed that if you collected seeds from the plants that produced the most grain and planted them deliberately, you could get more reliable harvests. They figured out that if you pulled out competing plants, your food crops grew better. They learned to select for traits they wanted: bigger seeds, thicker stems, grains that didn't scatter in the wind. They were inventing agriculture, not all at once, not with some grand plan, but bit by bit, trial and error, passed from generation to generation. By the time the Younger Dryas ended around 11,600 years ago, they'd done something revolutionary. They'd domesticated wheat and barley. They'd turned wild plants into crops. And here's the incredible thing. This wasn't happening in just one place. As the Younger Dryas stressed human populations across the planet, the same basic innovation was emerging independently in multiple locations. In China, people were domesticating rice and millet. In Mesoamerica, they were working with maize, beans, and squash. In New Guinea, they were cultivating taro and yams. In the Andes, potatoes and quinoa. In sub-Saharan Africa, sorghum and yams. 7 different regions, 7 independent inventions of agriculture. This isn't coincidence. This is what happens when you give cognitively modern humans a resource crisis. They don't just adapt. They transform their entire relationship with the environment. But here's where the story gets really weird and really interesting. At a place called Göbekli Tepe in modern Turkey, archaeologists found something that shouldn't exist. Massive stone structures, circular arrangements of pillars carved with elaborate animal reliefs. Some of the pillars weigh up to 16 tons and stand 18 feet tall. The craftsmanship is extraordinary, showing sophisticated artistic ability and symbolic thinking. Here's the kicker. Göbekli Tepe was built around 11,600 years ago, before agriculture. The people who built it were still hunter-gatherers. They hadn't domesticated plants or animals yet. They were supposedly living in small mobile groups following game and gathering wild foods. But somehow they were organizing construction projects that would have required hundreds of workers, coordinated over years, maybe decades. They were quarrying massive stones, moving them miles, carving them with sophisticated tools, erecting them in precise alignments. This isn't supposed to be possible. The old story of human development said civilization required agriculture first. You needed settled communities, food surpluses, specialized labor before you could build monuments or develop complex social hierarchies. Göbekli Tepe flips that script entirely. It suggests that hunter-gatherers were capable of much more complex social organization than we ever imagined. That maybe the drive to create sacred spaces, to gather in large groups, to build something permanent, that drive might have come first. And maybe agriculture developed as a response to the logistical challenges of supporting those gatherings. Think about it. You're a hunter-gatherer group in the Levant. Every year, you and dozens of other groups come together at this sacred site. Maybe it's for religious ceremonies, maybe it's for trade and mate exchange, maybe it's just for the social connection. But feeding hundreds of people from wild resources is hard, really hard. So you start looking for ways to produce more food more reliably in the areas around your gathering site. You start cultivating those wild grains more intensively. You start managing animal herds instead of just hunting them randomly. Before you know it, you're not hunter-gatherers anymore. You're farmers. And you didn't set out to invent agriculture. You invented it accidentally while trying to solve a different problem. This is how human innovation actually works. Not through grand plans, but through incremental solutions to immediate challenges, building on knowledge that's been accumulating for millennia. And once agriculture started, everything accelerated. Settled communities meant you could accumulate possessions without worrying about carrying them. You could build better houses, invest in infrastructure, develop new technologies. Agriculture produced food surpluses, which meant not everyone had to spend all day finding food. Some people could specialize. You got tool makers, basket weavers, eventually potters, metal workers, scribes. But agriculture also created new problems. When you're living in permanent settlements with dozens, then hundreds, then thousands of people, you need new forms of social organization. Hunter-gatherer bands could operate through personal relationships and informal consensus. Agricultural villages needed rules, dispute resolution systems, ways to coordinate labor and distribute resources. You needed hierarchy. You needed institutions. You needed, for better or worse, the foundations of what we call civilization. And there was something else, something darker. Agriculture created population pressure in a way hunting and gathering never had. Farmers could have more children because they didn't need to carry them constantly. But more people meant more demand for farmland, more demand for water, more competition for resources. Agricultural societies started bumping into each other, competing for the best land. They went to war, systematically. Organized violence on a scale that hunter-gatherers had rarely seen. The archaeological record from this period starts showing fortified settlements, weapons designed specifically for fighting other humans, mass graves from battles and massacres. The transition to agriculture wasn't some peaceful evolution. It was often brutal, traumatic, a complete restructuring of how humans lived and related to each other. Many people probably resisted it, but once it started, there was no going back. Agricultural societies could support larger populations, which meant more warriors, which meant they could expand at the expense of hunter-gatherers. Within a few thousand years, farming had spread across most of the temperate zones of the planet. And everything that came after, cities, writing, mathematics, organized religion, empires, everything we think of as civilization, it all traces back to those first experimental gardens planted during the younger Dryas. To people who looked at a climate crisis and decided to try something unprecedented. But none of it would have been possible without what happened 50,000 years ago. This is the critical thing to understand. The cognitive revolution, that moment when human behavior suddenly became modern, when we started creating art and music and complex tools and symbolic systems, that was the foundation for everything that came after. Agricultural innovation required the ability to think abstractly about cause and effect, to plan seasons ahead, to communicate complex information across generations. It required the social structures that let hundreds of people coordinate their efforts. It required the symbolic thinking that created religious sites like Göbekli Tepe. All of those capabilities emerged during the cognitive revolution. And here's what makes humans truly unique. It's not just that we can innovate. Lots of species can solve problems. It's that we can accumulate innovations across generations. every generation doesn't have to start from scratch. We inherit knowledge from our ancestors, build on it, and pass something even more sophisticated to our descendants. This is cumulative cultural evolution, and it's our superpower. A crow can figure out how to use a stick to get food. That's clever. But a crow can't pass that knowledge to thousands of other crows, refine it over centuries, eventually develop agriculture and civilization. We can. We do. We've been doing it for 50,000 years. From the first symbolic beads to nuclear reactors, from cave paintings to the internet, every innovation builds on what came before, made possible by our unprecedented ability to learn, share, and transmit knowledge. So when you ask what makes us human, it's not just our biology, though the cognitive revolution certainly had biological components. It's not just our tools, though our technology is remarkable. It's our capacity for infinite cultural innovation, our ability to look at any problem and invent new solutions, our talent for building on the past to create futures our ancestors couldn't have imagined. We're the species that survived the bottleneck, that endured climate catastrophes, that spread across the entire planet, that invented agriculture, cities, writing, science. Not because we're physically superior, we're not, but because somewhere around 50,000 years ago something changed in our minds. And we've been building on that change ever since, generation after generation, innovation after innovation, creating a species that doesn't just adapt to the world but transforms it. The journey from those first cognitively modern humans to the present wasn't inevitable. There were countless points where we could have failed, gone extinct, remained just another clever primate. But we didn't. We're here, 7 billion descendants of the survivors, still innovating, still adapting, still building on everything that came before. And the story's not over. It's just getting started. So here we are. The end of a journey that took 250,000 years to complete, but only about an hour to tell. And if you're feeling a bit overwhelmed by the sheer scale of what we've covered, you should be. Because this isn't just history. This is your history. Every single person watching this video right now is the product of this incredible journey. Think about what we've covered. 250,000 years ago, there were maybe a few thousand anatomically modern humans living in small groups scattered across Africa. They had the bodies we'd recognize today, but their minds, still developing, still figuring things out. They made simple tools, used fire, probably had basic language, but nothing about them suggested they would eventually dominate the planet. For the next 150,000 years, not much changed. Generation after generation living basically the same way their grandparents had lived, making the same tools, following the same migration patterns, surviving, yes, but not thriving, not expanding, not innovating at any pace that would make you think, yeah, these are the ancestors of the species that would build cities and split atoms. Then things started shifting. Around 100,000 years ago, we see the first hints that something was brewing in the human mind. Ochre pigments suggesting symbolic thinking. Shell beads indicating self-decoration and possibly trade. Tools that required more planning and skill. The signs were subtle, scattered, inconsistent, but they were there. And then, around 50,000 years, everything exploded. Not gradually, not slowly. Within just a few thousand years, humans went from barely hanging on survivors to the most dominant species on Earth. Sophisticated tools appeared everywhere. Art went from occasional experiments to systematic expression. Language became complex enough to share abstract ideas across generations. Trade networks stretched hundreds of miles. Social structures scaled up from small bands to complex societies. That's the turning point. That's the moment when humans became unstoppable. Not 250,000 years ago when we first appeared, not 100,000 years ago when we started experimenting with symbols, but 50,000 years ago, when all the pieces finally came together and produced the cognitive revolution that made us who we are today. Within 10,000 years of that revolution, humans had spread to every continent except Antarctica. We'd outlasted the Neanderthals, absorbed the Denisovans, crossed oceans, climbed mountains, adapted to deserts, rainforests, Arctic tundra, and everything in between. We learned to hunt megafauna to extinction, domesticate wolves, and create art that still moves us 30,000 years later. By 12,000 years ago, we were inventing agriculture. By 5,000 years ago, we were building civilizations. By 500 years ago, we were circumnavigating the globe. And today, we're sending robots to Mars and teaching computers to think. All of that happened because of what changed 50,000 years ago. That cognitive revolution. That moment when human minds became capable of abstract reasoning, complex planning, and cultural evolution that could outpace genetic evolution. That's what made us special. That's what set us on the path to everything we've accomplished since. And here's the thing, you carry that legacy in your DNA. Every person alive today is descended from those innovative, creative, adaptable humans who emerged from Africa carrying the full suite of modern, cognitive abilities. When you solve a complex problem, you're using neural pathways refined over tens of thousands of years. When you create art, you're expressing impulses that drove your ancestors to paint caves. When you cooperate with strangers to achieve common goals, you're activating social instincts developed during that crucial period. We're all products of the cognitive revolution, all evidence that sometimes evolution doesn't just change bodies, it transforms minds. But the story doesn't end here. We're still evolving, not just genetically though, that's still happening too, but culturally. The same forces that drove human innovation 50,000 years ago are still operating today. We're still solving problems, creating new technologies, developing new ways of organizing societies and sharing information. The difference is, everything happens faster now. Cultural evolution has accelerated to the point where the world changes dramatically within a single human lifetime. The challenges we face today, climate change, resource scarcity, the need to cooperate across vast differences, they're not so different from what our ancestors faced. They're just operating at a much larger scale. But if there's one lesson from this 250,000-year journey, it's that humans are really, really good at adapting when we need to. So, where does this leave us? Hopefully with a deeper appreciation for the incredible journey that brought us here. And maybe, just maybe, with some perspective on the challenges ahead. If you made it this far, thank you for joining me on this journey through human history. If you found this fascinating, hit that like button, subscribe for more deep dives into the story of us, and share this with someone who needs to know just how special humanity really is. And I'm curious. Drop a comment below telling me where you're watching from and what you think makes humans truly special. Is it our capacity for innovation, our ability to cooperate, something else entirely? Let's keep this conversation going. Thanks for watching. And remember, you're the product of 250,000 years of survival, adaptation, and innovation. Act like it.